Okay, 8.5 hyperbolas. A little bit different than what you've seen before. But we're going to use a lot of the same things we were doing before. We're going to be completing the square. But this time we're going to have some asymptotes. Okay, and so I'm going to show you that in a minute. The first one says hyperbola, the set of points in a plane such that absolute value of the difference of the distance from two foci. The foci is the blank, FOIC. I'm not overly concerned about that. I think I'm going to take that off for next year. All right, so let's look at the standard form of the equation of a hyperbola. Okay, a little different in that it has subtraction. So it kind of looks like an ellipse, except it has a subtraction between the two, and that's what's going to make the difference. That means your x or y is going to have a negative on it. And there's also directional for this. So let's look at the first way it could look. Again, it has a denominator like before, like an ellipse, and it has to equal 1. Okay? This is going to be, you're going to have a center at HK, and this is going to open left, right. And that is because the x is positive. If the x is positive, we're going to open left, right. So the x group is positive. So it's going to open left, right. Okay? Now let's look at a different form. So the other form is y minus k. Notice the y comes first this time over a squared. Minus, this time our x is negative, and so that's going to change our direction. Still, we have denominators. Still, we're going to have some major, minor axes. The center, we still do h first, okay? The center is still hk. But the difference is it's going to open up and down. Because the, whoops. Wow, did you know how you said that was creative use of time. And down. Because y is positive this time. So if y is positive, it's up, down. If x is positive, it's left, right. Okay? And so that's what it says there. If the x term is first, the hyperbola opens right, left. If the y squared term is first, the hyperbola opens up, down. Okay? Now let's look at this. It says every hyperbola have two axes of symmetry. So you should put 2 in that first blank. The transverse axis, the endpoints are the vertices. And I'm not going to worry about that length of 2a. I'm going to show you that in a minute. And the conjugate axis perpendicular to the transverse. Well, there's a lot of crap going on there. So let's just do a problem and see if you can understand it from a problem. Number 1. That's a part that I'm thinking I don't need. There's a lot of words that are confusing, but if I can show you how to do this, I think you're going to see that it just takes a little bit of practice. Okay, so the first thing I notice is we're missing a lot of points. This is not a circle, and the reason it's not a circle, it doesn't have the coefficients of the x squared and the y squared are not the same because the x is 1 and the y squared is negative 1. Therefore, it's a hyperbola. If either x squared or y squared is negative, only one of them is negative, then it's a hyperbola. So let me write this out. If you weren't sure what to do here, here's what's really going on, but we don't write all this because we don't fill in zeros and ones everywhere because that would be taking us a lot of time. But this is really what's going on with this one, okay? So the first thing we have to decide, is this going to be an open right, left, or up, down? And it's going to open right, left. And the reason is the x squared is first and it's not negative. So it's going to be open right, left. Okay? The center is always something we need to decide, is 0, 0. Now we're going to have to find the vertices. Now I'm going to show you algebraically and graphically how to find the vertices. Now here's what you're going to do. It's very similar to doing an ellipse, except instead of drawing an ellipse, we're going to draw an imaginary box and triangles. Here's what I mean. Let me do this in black, and let me get this. All right. So very similar to an ellipse. We start at the circle at the center, and our center is 0, 0. And let's look under our x value. Under our x chunk, there's a 1. Well, what's the square root of 1? 1. So that means in the x direction, we're going to go out 1, and we're going to put a little mark. Okay? In the y direction is actually also 1. because that's what's under the y. And we're going to make an imaginary box. And to show that it's imaginary, this isn't the actual graph. This is the asymptote that the hyperbola is not allowed to cross. And then we have to make a diagonal through the center. Again, asymptotes, boundaries, that our hyperbola is not allowed to cross. And here's where we can figure out our vertices. Our vertices, the one place it can touch our imaginary box is at that point. Okay, because this is open right, left, we're looking to the right or to the left. And so this is what a hyperbola looks like. We're skimming along the boundaries without crossing them. And this dot here and this dot here, they are our vertices. So you can read them right off the graph. And so in this case, our vertices are 1, 0, and -1, 0. Or if you want to do it algebraically, you can say how far left or right did we move from the center? Well, we started at 0, 0, and our left radius for our little box was 1. So we moved to the left one and we moved to the right one, and so I just add that to my center, and I can see where I ended up. Okay, so you can kind of do it by looking. I kind of look first, and then I think about the algebra to kind of see what's going on. Okay, this video might be a little longer because hyperbolas are a little bit more. Actually, I only have 2 more problems, so maybe it won't be as bad. Okay, let's look at number 2. Yeah, I only have 2? Yep, okay, good. Number 2 looks like this. It's already in perfect form. It has x with its little center. It has a denominator. It has I know it's a hyperbola because of that subtraction, and it's equal to 1. There's nothing I need to mess with. So let's talk about this. The center, again, be careful when they're out of order. The y is in first place here. So over here at the second one is where our h is coming from here, and this is our k. And remember, we have changed our signs. So it's -2, +4. Okay. And then we need to know, is it opening up or down? Up, down, or left, right? Well, who's coming first in this problem? The y did. The x is negative, so the y is positive. So this is going to be an up-down opening parabola. And again, I leave the vertices till after I graph, because sometimes it's just easier to look at my graph and see what my vertices are. But it's kind of up to you. You could do it algebraically from this point. This is where I have started to use some of my conceptual. I know if I look at it first, it's going to give me an easier time knowing where my vertices are. So I like to kind of have the picture conceptual first. All right, so here's my graph. Let's put our center at -2, 4. Okay, I might need more room. All right, in the x direction, let's look back at our equation. What number is under x? The number under x is 9, so we need to square root that to know our radius from in the x direction. So 1, 2, 3, 1, 2, 3. What's the radius in the y direction? That's going to be 4. 1, 2, 3. I got to fix this. This isn't going to work. Hold on. Let me fix it. I need more room up there. It's in the upper left quadrant, so the second quadrant. So let's make it a little more room here. Okay. Our center was at -2, 4. The square root of 9 was 3, and that was under the x, so we're going to move this way, 3. Then I look at what's underneath the y is 16, the square root of that is 4, so that's my radius. And now I'm going to make my asymptote box. Okay? These are my boundaries, and then my diagonals. You want to use a highlighter to do this, or if you want to do it, okay? Now we know this has to open up, down, because the x is negative and the y is positive. So that means my vertice is going to be right above my center, and then we're going to go this way. And my other vertice is going to be below and go this way. So now I know what my vertices are, either by reading it off my graph, or I know that I moved 4 away from my original center, so I can add 4 to the y value of my center. So it's going to be, that means my x's don't change. My x's don't change because I'm doing up, down. So I left -2. And then I was at 4, and I went up 4, so that's going to take me to 8. I was at 4, I went down 4, that's going to give me 0. So that's my vertices. Or you just read them. Again, they're these points right here. If you make a nice, neat graph, you can just read them off the graph. Okay, so they're your vertices. All right, let's do the hard problem. Here we go, number 3. We got this. You know how to complete a square. You're good at it. X squared minus y squared plus 6x plus 10y minus 17 equals 0. The reason I know this is a hyperbola and not an ellipse is because if you look in front of the x squared and the y squared, they have opposite signs. As soon as you see x squared and y squared have opposite signs and they're on the same side of the equation, you have a hyperbola. But this is a mess, so let's put it together. We have x squared plus 6x here. And then we have negative y squared plus 10y. And I'm going to move that 17 over so it becomes positive 17 over here. But then I notice a problem. I was just going to put a triangle. But my y squared is negative, which we expect because it's a hyperbola. So before we do any completing, I can't just divide everything by negative like we did with circles. Or was it with parabolas? I have to put it on the outside. So really I'm taking a negative 1. Let's see if I can do this right. Off of just these two. So this would be negative 10y. And then I'm going to put a triangle here. But really, what type of triangle was that? Well, if we distribute back through, that was a negative triangle to begin with. And then I took a negative off of it. So really over here we have 17 and a negative triangle. And over here we didn't have to do anything. So this is just going to be x squared plus 6x plus a square. And now we're going to complete the squares. Okay? Again, x, half of 6 is 3. Square, that's what goes in the boxes. I forgot to put a box over here. So 9 goes over here. Okay? And then I have a negative 1. And then I'm just going to complete the square. Y minus 5, because half of 10 is 5. Squared is 25, what goes in the boxes. Okay? And that's what I have right now. Okay? Make sure I've got this right, because I did a lot of redoing on this. Okay. Now the problem is... Oh, I forgot. All of this needs to go together, right? So 17 minus 25 plus 9, this works out kind of nice, equals 1. So if we have a 1 over here, we don't have to divide both sides by anything. We already have our 1 there. If there wasn't a 1 there, then we'd have to divide everything by 1. All right, so then our center is negative 3. Positive 5. I almost forgot to switch it. I don't know my vertices yet. What's underneath both of these? Well, 1's underneath both of these. So that's all I need to know. Are we moving left, right, or up, down? Well, the x is positive, so we're going to move left, right. So let's graph it. I don't know what color I'm graphing. Let me make sure I have room, not like last time where I ran out of room. All right. So let's put our 3, 5 on there. 1, 2, 3, 1, 2, 3, 4, 5. In the x direction, we're just moving 1 radius. In the y direction, we're moving 1 radius. And we make our little asymptotic box. We already decided this was going to go left, right. So that means these are my 2 vertices. I moved 1 over. So that means my vertices, my y's didn't change. So I leave my y's alone. And I moved to the right one. So that's going to be, oh, crap, darn it. Do you guys see what I did? I'm in the wrong place. I was trying to go fast to make your video shorter, and I screwed up, so it makes the video longer. Okay, well, you know. You can see more of my mistakes. Okay, let's try again. Let's do our invisible. It's negative 3, 5. 1, 2, 3, 4, 5. I noticed when I started doing my vertices, they were wrong. Then we go out 1, 1, 1, because that's what's underneath of those. And now we draw diagonals. And then our vertices will be here and here. So we moved 1 over to the left, so that makes negative 4. And we moved over 1 to the right, so that makes negative 2. Okay, that's a hyperbola. You might need to listen to again, because I kind of went